Okay, so today we are going to talk about MyPy, and I'm very grateful that Brandon was able to make it to the meeting today because he knows more about MyPy than I do, and so if he wants to jump in and correct me at any time, he is free to do so. I only started using MyPy in earnest about a week ago, but it means it's all fresh in my head, and I've just recently dug through the documentation, learning about it and using it. So hopefully I can convey my experience to y'all as well as possible. So MyPy is a static analysis checker. It's like a linter for Python, and what you use it for is what you do is you decorate your Python variables and function signatures with types. Now, these are annotations. The Python proper does not enforce them, but you can use MyPy, assuming that you've set them up correctly. MyPy can tell you whether or not those variables are being used in a way that is rational. So, for instance, you can declare a variable to a function as an integer, and if somewhere that function is called with a string, MyPy will call that out and tell you this function is being called with an inappropriate argument. Likewise, in the function itself, if you are doing things that are not doing operations on that variable that are not appropriate for an integer, it will call them out and report them as errors. So this is useful. It's meant to be a useful medium between a duck-typed language and a fully static language, as far as error checking goes. And so what we're going to do today is go over some examples of how to do that annotation. I'm going to do this from the perspective of Python 3, specifically Python 3.6, because there are a few things that I'm going to show that are 3.6 only, and I will try and remember to call those out when I get to them. And you can use MyPy in Python 2, but the annotation functionality is not available. You have to do it with annotation comments, and we're not going to cover that. We're just going to cover the we're just going to stick to the Python 3 functionality. So the documentation for this is at mypy.readthedocs.io, and I will go ahead and post this in the chat for the meeting if you want to follow along. And their cheat sheet for Python 2 and Python 3 are both excellent, and so that is primarily what I'm going to be working off of. And then what we'll do is we'll write some code, and then over in my terminal we will run MyPy against the code and see what kind of errors that we get, and see what kind of reporting that it can do for us. The other thing is that if you don't annotate your variables and you don't specify their type, MyPy just assumes that they can be anything, and so it doesn't do anything with it. So if you try and run MyPy on existing code, there's not a whole lot that it can do with it. It can do some things like implicit typing based on initial assignment, but beyond that, it's not going to do a lot for you. So to install MyPy, it's simply pip install MyPy, which is, I've already done that here, and that will go ahead and install it for you. It's a pure Python module, so it'll work everywhere. There's nothing that needs to be compiled as far as I know. Okay, so so here we have main.py, which is completely empty. And we're going to declare some variables, and we're going to look at how we do type annotation in Python. Now, this is not specific to MyPy, but this is the feature that MyPy takes advantage of. Type annotation our variable annotation was released with MyPy in mind, though. And so you'll see in the MyPy documentation, they'll refer to specific Python enhancement proposals that talk about type annotations and how to use them properly. And so some of the, there's some notable gaps in the MyPy documentation that I found. And you have to refer to the PEP to understand how to actually do what they're talking about. And I will cover that one specific case of that here shortly. So let's talk about variables. So we're going to declare a variable named age, and normally you do something like age equals 1. Well, it's starting with let's see, starting with Python 3. This is the 3.6 or newer stuff. You can annotate this variable with a colon and then a class instance. So in this case, we'll declare this an integer. So now we have age, and we've said that this is set to 1. Now, this is not required, of course, because it's still regular Python, but this is not enforced by the Python C runtime. So this is just an annotation that other utilities, such as MyPy, can use later. Pre-Python 3.6, you can do the same thing, but you have to do it with a type comment. What do they call this? An annotation comment. So let's see, space, and then we specify the type int, and that's equivalent to the first line. But we're just going to ignore this form because it's more tedious, and we're going to use the new form because I'm working in Python 3.6 here. Okay. Also, it is not actually required that you assign a variable to A. So if you have like a conditional statement where A is defined is assigned in each condition, you, instead of declaring the type everywhere that that variables can first potentially be created, you can preemptively declare the type without assigning a value to it, like this. And this is essentially in C Python is considered is treated like a no-op. Okay. So then we can do something like so the example that they use in the example is we do child, and we declare that a Boolean, and then if age is less than 18, child equals true, else child equals false. And yeah, there's more concise ways of expressing that, but that we're going to stick with that one. Okay, so now we have a simple program that doesn't really do anything, but it's here, it's handy. So we're going to come over here and we're going to run MyPy on this program. And it's simply a matter of running mypy.main.py. And I haven't run MyPy. Okay, so we come back with no errors. All right. Well, let's try and do something that's incorrect. So let's say child equals 0. And this should fail. Yep, MyPy error, incompatible types in assignment. Expression has type int, variable has type bool. So these are the kind of errors that you can expect to see from MyPy if you do something that is uncool. So something like that. Now, for simple built-in types, so in general, you can put any type after the colon, and MyPy will do the right thing. So for instance, we can do x, let's see, float equals 1.0, x, let's see, let's do string equals test. So, you know, stuff like this. We can do x equals bytes, UITES, equals, and then a byte string like that. And these are all considered, so these will resolve without an error in MyPy. X already has, okay, so now it's actually, MyPy is pointing out a different problem in that we are redefining X with a different type. And it doesn't like that. Now, this is certainly perfectly valid Python code because there aren't really any, we can reassign X to whatever variable we would like. But MyPy is pointing out the fact that we're doing this and we probably don't want to. Okay. So let's go ahead and get rid of this. So what about things like lists? So you would think that you would do something like this for a list, but this is not actually what you want. So this included in the Python standard library is the typing module. So we go from typing, import, and then we have list, and note the capital, set, dict, all of your basic types, tuple, T-U-P-L-E, and then optional. And optional is a special one that we'll get to shortly. So now if we want to declare X as type list, we use the capital L, and then using square brackets, not parentheses, we specify in the brackets the type that we want the items in the list to be. So we would say list, we would say int for integers, and then we could put like a 1 and a 2 and a 3 and stuff like that in there. And so if we run this, we might get some errors for our unused imports. No, we don't get errors for the unused imports. That's good to know. But this tells us that when anybody is working with X, we are typing X as type of list event. So if we do X dot append and we append a float, when we run MyPy, that will result in an error. Argument one append of list has incompatible type float expected in integer. Okay. Same thing with sets. The sets are pretty, we can do a set of integers, and then we need to change this to curly braces to get the set constant. And in fact, if we forgot to change out the curly braces, it would complain that we were trying to assign a list to a variable that's supposed to be a set. So then we have dictionaries. So dictionaries take multiple arguments. Square bracket, so we do the key type and then the value type. So we could do like string and float. So this is telling us that we expect all of the keys in our dictionary to be strings and all the values to be floats. And then if we just assign this, we can do something like this, where we can go test and then 2.0. And so that would be considered a valid declaration of X. And then if we add anything to X or do any updates to the X dictionary during the static analysis, it will check to see if the new values that are going into X are of the appropriate type and key and value types. Okay. So then tuple is what it sounds like. We're declaring a tuple. We're declaring that X is a tuple, but we have to specify the length of the tuple and the types of each value in the tuple. So we're going to do something like, let's see, T-U-P-L-E. And then we'll specify our types. And let's see, int, string, float, something like that. And then we have to declare a tuple. And let's see, 3, foo, and then 7.5 or 1.0, something like that. So that would be a proper declaration of a tuple. Now, Optional is intended for, so if we just go ahead and run that, yep, that works. Okay, so then optional is where something could optionally be none. So optional goes around other types, much like list or tuple. You know, you say optional, and then you'd put a type inside of it. So we could actually do this, optional, and then we come over here and close it off. And so now what we say is that X can either be a tuple of this particular shape or none. So that's what optional means, is that this value is optional. So if we have a function that may or may not return a string, it'll return a string or none. We can do this. So foo, some function I haven't defined, and that way it knows that if foo returns, if foo is going to return none or a string, then this is that we are telling MyPy that, yeah, this is not the fact that this is going to be a string is not set in stone. It can also optionally be a none, and you'll see optional used a lot for keyword arguments that that default to none. You'll see that all over the place. Let's see. Okay. So Python 3 supports annotation function syntax, or supports annotation syntax inside of functions. So let's see. But this is a little bit more interesting because there's more possibilities with what you can do for arguments of your function. So we have callable, iterable, union, and union is actually very important. Optional, and then we'll throw in list for our examples here. Hold on. Excuse me. All right. So let's look at an example of how to do this. So if we do def stringify, we could specify our variable name, and then like we do for other variables, we specify a colon, and then we specify the type. So we're going to stringify an integer, and then we need to specify the return type. So we do that with an arrow, and the type that we that our function is meant to return, and then we put our colon in, and then we do return string num, like that. And then when we call, string, so we can call, let's see, so print, well, I'm not even going to print it because we're not going to actually run this stringify. And so if we do 7, that's fine. If we do stringify 7.0, that's a problem. So if we run MyPy, we'll see that we get an error on line 9. Argument1 to stringify has incompatible type float expected integer. So what if I don't care whether it's an integer or a float? So this, you would do import numbers, and you can actually put in numbers dot number, and this should allow it to accept any number type. And so if we do stringify ABC, that one should be the only one that produces an error. Oh, expected type number. Okay, so I've done something wrong here, and maybe Brandon has a better way of doing this. But according to this, int, you can also do like parent types. So like if I have a variable of a particular type and I pass it in a child of that class, it should just work. And in fact, normally it does. So in this case, though, My understanding is that the way you're supposed to handle this is with a union, and then you specify all the types that are valid in the union. So we can do int, we can do float. I'm going to leave off string because I don't want to handle that one. And now we only get an error for line 13. Brandon, do you know of a way to handle numbers generally in MyPy? I was under the impression that eventually that you were going to be able to import numbers and just use like numbers real or numbers or something like that, and have it still work. Do you know if there's a way to just say like generically all numbers instead of doing a union of the particular number types that you care about?
No,
Okay.
I haven't run into that yet.
Okay. This came up in something I was working on earlier this week, and I ended up having to do this union here. Originally thought I could just do the import numbers. There is an open ticket on this in the MyPy issue tracker, and I think they're thinking about a more elegant way of handling this particular case. But yeah. So I mean, if we did float and not int, or vice versa, they are not considered equivalent as far as type is concerned. So that it's not like they're assuming uh, uh, recasting like uh, they're not assuming the same kind of recasting that you would see in like C, where if you passed an integer where it expected to float, or vice versa, it would just coerce it into the appropriate type.
I think there is a way. I think they have a. I think there's a way to say that you can accept anything that supports the dunder int method.
Okay.
Right. So a float can be converted to an int, so it would be accepted. I haven't explicitly played with that, but
Okay.
I would expect that that works.
Okay. Um, I think that's going to be outside of the scope of this discussion then, because I wasn't planning on getting that deep into it. So we'll just leave that on the table for today. So let's look at some of our other examples here. So let's see. You can, of course, specify multiple arguments. So we can do def plus and then num1 int num2 int, this kind of thing, and then let's see, the return type of integer, and then return num1 plus num2. Yeah, so that kind of thing works as the way that you would expect. They do have an alternate example here in the documentation, which I will just cut and paste because it dovetails into the third thing. So we can, if you're doing key value arguments, you just specify the type before it. You specify the variable the same way, and then if you want to specify the value for a keyword when you need to specify the value for a keyword argument, you go equals and then the value. This is where optional becomes really useful, because if this like defaults to none, but it's it's, if they're going to give you a value, they're going to give you an integer, you would say optional int or something like that. So now we have a function. So the signature of our function is it takes an integer and a float and returns a float. So what if we want to assign a variable to this function? You know, something like x equals f, that kind of thing. So how would we do that? So we would specify callable, and then we would describe the signature of the function that we're expecting. So our we do that with two arguments. One is a list of the arguments to the function. So int, float, and then the second argument is the return type, which is going to be float. So let's get this right here. So callable equals f. And so that's how you would tell MyPy that we expect this is expected to be a callable object with this signature. Okay. Generator functions use the iterable return type, so def f of n int, and then our return type, since this is going to be a generator, is an iterable, and our iterable is going to return int, is going to produce ints. And then we just do I equals 0. You know, this is something simple. While I is less than n, yield I plus equals 1, something like that. Now, in this case, MyPy will infer the value of, or the type of I from our initial assignment of I equals 0. And then it's got everything else it needs for somebody who wants to use this function to know that they're using it correctly. Let's see. Let's see. I've already talked about optional keyword arguments. You can also declare an argument as positional only. So in case you've forgotten, positional arguments can be supplied with keyword argument pairs, with argument value pairs, as long as you supply all the positional arguments. You can specify that a particular argument is positional only by starting it with a double underscore. So something like this. And then we'll return none. And then pass. Okay. So this function can be called like this, but MyPy will complain if we call it like this. That's considered an error. And in fact, let's go ahead and run this. F already defined. Unexpected keyword argument double underscore x for Quux. Note, Quux defined is on line 29, so it's telling us where we can find the definition of the function if we're interested in it. Okay. Are there any questions so far? I've kind of been rattling through this pretty quickly. Okay. Let's see. So if we okay, they've got a bunch of examples here that we've already pretty much covered. Okay, so what if you want to do duck typing? Like you want MyPy to say, yeah, you know, it doesn't have to be a dictionary, but it has to have something with a dictionary interface. So how do you do that? How do you do that in MyPy? So let's go ahead and touch 2.py. Let's start a new file here. So if we wanted to do, so they have special types that you can do comparisons with for enabling duck typing while still having the static typing of MyPy. So so let's look at an example here. So let's say we have a function f, and it doesn't necessarily need to take a list, but it needs to take something that we can iterate over. And we don't care if it's a set or a list or a view into dictionary values or anything like that, because those are all different types of objects. And so if we want to make it more flexible, we say iterable int, like this. And then we can pass basically anything that can be iterated over that contains integers. MyPy will say that that's good, and then we'll return a list of strings, and then return. I just got to copy and paste this. There we go. So then we could do something like that. And then anything that we can do for x in ints on any item where that this interface will work, MyPy will not throw up any red flags. But if we try and pass it something that is not iterable, an iterable that will return integers, then it will fail. So we could pass in. So in this case, if we passed in a set of ints, it will work just fine. If we pass in a string, which is iterable, but does not return integers on every step, that will cause MyPy to complain. Let's see. If we want to do some sort of mapping, if we want to emulate the mapping interface, we use mapping or mutable mapping for our argument. Mapping assumes that the mapping is immutable. Mutable mapping says that we're going to use things, use the interface to actually modify our dictionary. So we specify the mapping. So we say if we give it an int, we'll get back a string, and then we're going to return a list of integers. And then we just use the mapping interface keys to get an iterable of all of the keys in our mapping object. And so then it doesn't matter whether or not we pass it a dictionary or something that emulates a dictionary, or some child of the dictionary. Well, actually, even if we asked for a dictionary and then we passed it like an ordered dict, that would work. But mapping says we're not actually restricted to dictionaries. We're restricted to things that look like dictionaries, which, I mean, this is Python. That's really what you're shooting for. Okay. So when we define a class, let's go ahead and create another file here. If we define a class, classes, when you create a class in Python, you're essentially creating a type. And there are things that you're going to want to do in your class to define types for MyPy. No space. Okay, so there's two places where you can specify the type of your different variables. The first place that you can do it is at the class level. So you can do something like adder int, something like that. But more commonly, what you'll see, at least in my experience, this is at least my experience using MyPy, and different people probably will use it differently, is optionally you can, in your constructor in itself, when you first assign the variable, you go ahead and declare the type there. something like that. So this is a lot of times how you'll see it done, although it's also valid to do this. And then you can leave this out later. Those two are equivalent. When you return from, because your constructor should never return anything, you can also specify the return type of none with a capital N. And yeah, and then MyPy will do the right thing. Declaring functions in your function, in your class. You do not declare the type for self because it's redundant. And it can figure it out implicitly, but otherwise, you're going to want to include your types in your function definition. So, and then you can of course return the return type the same way that you would any other method. So return num times dir1. Okay. So that's all fine and dandy. So what if we want to declare a variable that's an instance of this class? Well, you can use any type that you previously declared as a type for your annotation, like that, and that will work the way it's supposed to. Why is it complaining about method? Method may be static. Yeah. Okay. So this works the way that's intended, and we can use my class this way anywhere we would like. We can use it as an argument to the list type, to the dict type, all that stuff. If you want to declare a class variable, so you'll notice in here that this is normally how we would declare class variables. So if we did a adder equals 4, that would be the class variable for my class equals 4 instead of an instance value. So if we want to declare a class variable, we would do something like this. We would use the class var object, and this is imported from typing import class var, like that. Oh, let's not forget list here. Okay, so then these are actually class variables that we've created here. Let's see. Okay, so now this is how we would assign an instance of a class. What if we wanted to do the type of a class? And this has come up where I've needed to pass a class type as an argument to a function in my code. So the way that you would do this is you would say x type, and then you would say my class equals my class. Now, what this is more useful for, let's see, is this technically correct? No, it is not, because this is only for the type of my class. This is not for children of my class. So the way you do that is with a type var. So a type var is where you say, and I'm just going to call it MC, equals type var, and then you give it, let's see, you give it a name, and we're going to say it's MC, and then you give it a upper bound, and the bound is makes this more flexible. Oh, why is it complaining? Unresolved reference to my class. I don't know why it's complaining about that. Well, we'll give it a shot here in a second. So then if we wanted to declare X to be of anything that is my class or inherits from my class, we would do type.
It's complaining, Kyle, because that's you're creating a class instance. It should be parentheses, not the square brackets.
Okay. Wait, here?
Correct.
Okay. Thank you. I couldn't remember. It used square brackets everywhere in this, and I couldn't remember how to do that. Okay. And then this is complaining because I don't have 2 lines. Okay. So then we have X is of type MC equals, and then my class, or we could assign X to anything that inherits from my class in this case. So this is how you would handle the case where you need to pass a class type in, and you've got a base class and then a whole bunch of different stuff that inherits from it. You can pass any one of those in, and it uses that for, like, say, a factory function or something like that. This is how you would handle that case. This is how you get the type of a class or any of its children. So that was the only thing I had a lot of trouble figuring out from the documentation. It's not in the cheat sheet, and it's not immediately apparent from the documentation how you do this. I actually had to go read the PEP to figure it out. And so if we run this, yep, it's not going to complain. All right. I won't cover coroutines and sync.io. Oh, this is fun. So there's also, let's see, we have match. In fact, let's go ahead and create a new file for this. Oh, let's see. I didn't actually run this on, there we go. Okay, name X already defined on line 11. We know about that. We don't care. Touch main 4.py. So 2 more things I'm going to cover. That's match, well, 3 more things. Match any string and IO. And I'm just going to copy and paste this so we're not here all day. So typing match describes a regex matches from the RE module. So this is actually pretty cool. So we do X match string, let's see, str equals RE match, and then we give it a pattern. So let's do raw string, and then we're going to do 1 or more characters from, let's see, we need a plus, okay, and then let's say 15. Okay. So the match type describes regex matches from the RE module. Actually, that's not quite what I was thinking it was. So this describes a match to a string object. So that it's the thing that RE match returns, which is it's an RE match object. It's a convenience for dealing with match objects from the regular expression. So that was not quite what I was thinking it was. I thought it was a little bit more something a little different. So IO is for returning objects that you would get any type of object that mimics the uh, um, uh, the what's the word I'm looking for? The anything that mimics the interface that you would get from the object that's returned from an open call. So like, open foo f equals io, and this is going to be string like that. No, I'm doing this backwards. So, oh my goodness. There we go. Jeez. So the IO type is file objects, the standard in, standard out, standard error objects, basically anything that emulates that interface. So has a write method, has a read method, has can be iterated over, that sort of thing. So that's the IO object. And then the last one is any string, which where do they show that? Any string is for any string type. So in this case, any function that'll accept a byte string or a Unicode string. Any string will encapsulate that. And then the last thing we should talk about is forward references. So if we want to reference a class that we define in the future, we normally we would specify it by giving the type. But if we define it later in the function, we can preemptively declare it using a string, and that's telling MyPy that further on in our code we are going to see a definition for this class. So if we haven't defined A yet and we do this, that will fail. But if we do this, it will succeed. And then as long as we define the class A sometime later, MyPy will pick it up and do the right thing. Okay. That's all I've got. Brandon, is there anything you would like to add?
The only other thing I think is worth mentioning is optional, since it's a pretty common thing you're going to run into.
I did mention it at the start.
Oh, okay.
Yeah. So just a reminder for what Brandon's talking about. If you have an argument if you have a variable that could be a value or none, you can declare it as optional, commonly used for keyword arguments in functions, so that you can have a default value of none and then supply, say, an integer or a list of strings or whatever. You would wrap that in the optional type. So, okay. Yeah, that's yeah. Thank you for your help, Brandon. I hope everybody enjoyed this. Are there any questions? If not, we'll call it a meeting. Thanks for coming out.